be this region. And since the question asks us to show the region on the graph that contains the set of points for which this 2x plus y less than 3. So it is these points. This point that is shaded. These are the points that we are talking about. This is the region. So that is the answer to that question number 1. Then question 2. Show on a graph the region that contains the solutions of the simultaneous inequalities. So here we are given a simultaneous inequality. That's to tell us that we have more than one equation that occur simultaneously or at the same time. So here we have 2x plus 3y. 2x plus 3y less than 6. Then we also have y minus 2x less than or equals to 2. Then we have y greater than or equal to 0. So these are the 3 equations that we have. So we are asked to show the region on the graph that contains these equations of inequalities. Now, the first thing we have to do is to consider our coordinates. But let's consider our coordinates. But before we consider our coordinates, we have to make y the subject of the formula. So we have 2 plus 3y is less than 6. Then 3y will now be equal to 6 minus 2x. When we divide both sides by 3, divide this by 3, we have y less than, divide this by 3, we have 2 minus, when we divide this by 3, we are going to have 2 over 3x. So that is what we're going to have. Then when x is equal to 0, okay, let's say here, let's consider the boundary line. The boundary line, which is y equal to 2 minus 2 over 3x. So that's the boundary line for this first case. Then when x is equal to 0, then our y will be equal to 2. So the coordinates are 0, 2. Then when y is equal to 0, then our x will now be 2 over 3x equal to 2. Then we cross multiply this. We cross multiply this, we have 2x equals to 6. Then our x will definitely be 3. So this one is 0, 3. That's the second coordinate. Then for the second equation, which is y minus 2x less than or equals to 2, we make our y the subject of the formula. We have y less than or equals to 2 plus 2x. Then the boundary line, the boundary line, which is y equal to 2 plus 2x. Then when x is equal to 0, then our y will be equals to 2. Y will be equals to 2. That's the first coordinates of x and y. Then when y is equal to 0, when y is equal to 0, we have minus 2x equals to 2. Then that will be, x will be minus 1. X will be minus 1. So we have the coordinates minus 1, 0. That's the coordinates. Then the last case, we have y is greater than or equals to 0. Automatically, that means y is equal to 0 or greater than 0. That is at least 0. Y is at least 0. So these are the 3 points that we are going to consider before sketching our graph. So by so doing, let's now sketch our graph. Now we are to make use of the coordinates to sketch our graph. We have 0, 2, 0, 3. This should be 3, 0, because x comes before y. That's the way we have x and y coordinates. X comes before y. So since our x is 3, 0, then here we have 0, 2, then we have -1, 0. Then we have our y to be greater than or equals to 0. So if you are to sketch this graph, this is our, let's say this is our y axis and this is our x axis. Now, the first point, so this is our origin. Let's say this is 1, this is 2, and this is 3. This is 1, this is 2, and this is 3. This is -1, this is -2. This is -1, and so this is -2. Now, when our x is 0, our y is 2. So at this point, when our x is 3, y is 0. At this point. For the second case, when we can resolve this first case, we know the 2 points, so we just sketch a broken line. That's a broken line will serve as our borderline. A broken line will serve as our borderline. It goes on and on to touch the third point, as in the second point. So this is our borderline, and the borderline there is what? Y equals to 2 minus 2 over 3x. That is our borderline. Then for the second case, we have when x is 0, y is 2. It's still the same points. The same points. Then when x is -1, y is 0. So this is the point. So we try to consider our borderline again here. The borderline, as it is usually denoted by a broken line. So it passes through this point. Pass through the coordinates. This also passed through the coordinates. Then the last one, which is y is greater than or equals to 0. Automatically, that's y is equal to 0 will definitely be the borderline. So it will be directly, okay, when y is equal to 0 will be on the borderline. Automatically, it will coincide with the vertical axis. So by coinciding with it, that means although you will not be able to see it clearly, but it is coinciding with the vertical axis. Coinciding with the vertical axis, just like what you have. So it's more or less like the vertical axis. So automatically, we can see that we are looking we are looking at a triangle here. Let's say this is A, B, C. So the solution of this graph will be in the triangle. The solution of the graph is in the unshaded triangle ABC. So this side will be shaded, this region will be shaded, this region too will be shaded, this region too will be shaded. So where you don't have shade is just the triangle, which is ABC, and that is this, where the solution will be. The question number 3 of the exercise: solve graphically the simultaneous inequality. Inequalities: 4x plus 3y equals to 12. Y is greater than or equal to 0, and x is greater than 0 for integral values of x and y. For the question 3, we have 4x plus 3y is less than 12. Then we also have y is greater than or equal to 0, and we have our x, which is greater than 0. So these are the inequalities, simultaneous inequalities. And the question asks us to solve graphically. So the first thing we do here is to take care of the first one, which is 4x plus 3y less than 12. The next step is to make y the subject of the formula, which has been the trend we've been following all along. So here we make y the subject of the formula. Then the first thing we do is to transfer this 4x to the other side, because we treat this inequality sign as if it was equal sign. So this, we transfer this to the other side, then we have 3y is less than